Hi, my students and friends. Welcome to class. Welcome back to class. Today I want to teach us how to solve problems on heat, how to calculate problems, questions on heat. Let's take the question so that you understand it better. But before I read, listen to this interesting explanation. It is quite interesting to know that some of the concepts, some ideologies that we study in physics is what we live at in our everyday life. Yes, it is quite interesting to know that. For example, we are told that we have energy, what is called energy. And we also told that this energy exists in different forms. We have different forms of energy like heat energy, chemical energy, solar energy, mechanical energy, and other forms of energy. And we also told that this energy can never be created, nor can it be destroyed, but it can only change form. It can change from one form to another. It can change from maybe mechanical energy to heat energy, from heat energy to solar energy. It can change from one form to another. Yes. And this is what exactly takes place. This is what comes into practical application whenever we are using electricity to cook or to do one or two things in the home. What happens actually is that the electric energy which we draw from the mains, from the socket, now will be transformed to heat energy which help our work to be done. For example, if it is cooking, the electric energy will now change to heat energy which helps to cook our food or which irons our clothes. And you know what? The total amount of electric energy that is generated from the electricity is what the other body gain. So in physics, there's a way we say it in physics. We normally say that energy gain is equals to energy loss. And that is what we actually have on the board. Let's read the question so that you understand it better. I read. The question says 2 kilograms of water. The question says 2 kilograms of water is heated with a heating coil which draws 3.5 amperes from a 200 volts mains for 2 minutes. What is the increase in temperature of the water? So we are solving to get a temperature or rise in temperature. Yes. Our solution here will be to get this temperature. Let's go. Specific heat capacity of water equals to 4200 joule kilogram per Kelvin per watt. From the question on the board, we are made to understand that a heating coil was used to heat 2 kilograms of water, which means electric energy was converted to heat energy. Yes, electric energy was converted to heat energy. In case of electricity like this, in electric cases like this, we simply say that heat generated from electricity is equals to heat given out to the other body, or heat produced by electricity is equals to heat gained by the other body. Let me write it out so that you understand it better. Let me write it out. Heat produced by electricity is equals to heat gained by the water that is being boiled with electricity. Heat gained by water. Now I want to write this formula. Everything in physics goes with a formula, so I want to put down the formula and start solving. Okay, but before I put down the formula, let me look at the data given to us, because that will make me to know the formula to apply. So if I write that type here, that is the information in this question. The first information I see here is 2 kilograms, and mass is measured in kilograms. So I write mass which is noted by M is equals to 2 kilograms. The next one is what it is, 3.5 amperes. Ampere is current, so I write current is measured in amperes, so I write current which is noted by I is equals to 3.5. Okay, what other information is given to us? I see 200 voltage, so volts given by V is equals to 200. Any other information? Yes, I see minutes, time, 2 minutes. So I write time denoted by T is equals to 2 minutes. 2 minutes. And you know that minutes is not the standard unit of time. So we have to change this minute to second, which is the standard unit of time, before we use it to solve. So to change it, I say this 2 times how many seconds make 1 minute? 60 seconds make 1 minute. So I write times 60. Which should give us what? 120 seconds now. 120 seconds. Okay, let me read it out. I read it out like this. So now I come back to the question again, because from this data now I know the formula to apply to solve the question. So they give us m, which is mass, give us I, give us v, give us t, give us s. Okay, so for electricity I use the formula I because of this I, v because of this v, and the t is equals to, I come to water. I see mass, which is 2 kilograms. So I use m, I put m. What other thing? They give us specific heat capacity of water 4200, and specific capacity is represented by small c. Finally, they ask us to find the temperature. So that will make this one to be completed. Temperature. Okay. Now I want to substitute these values into this formula. I start from the first one. I, which is current, is 3.5. So here I write 3.5. I come to the second one. There's invisible times there, so I put times. Voltage is what? 200. 200. Time is what? 120 times 120. Put my equals to. I come to this side. Mass is what? 2 kilograms. I write 2 here. Specific capacity is what? 4200 times 4200. Theta is what? That is actually what we are solving for. The question says, what is the increase in temperature of the water? So we are solving to get the increase in the temperature of the water as the water was being boiled by electricity. So we are looking for theta. So times theta. We continue. We come to this side. We evaluate, and we say 3.5 times 200 times 120. Let's calculate it. We say 3.5 times 200 times 120. It will give us what? It will give us 84000. To give us 84000. Put our equals to. Then we come to this side and we say 2 times 4200. It will give us 8400 times theta. So because we are solving to get the value of theta, which is the increase in temperature during the heating of this water, yes, we will make this theta now the subject of the formula. So I write theta is equals to this theta is equals to, I write this number 84000 over the number with theta now will come down, and it will be 84000. If this cancels this, yes, if this divides this, what we will get? What we get is equals to 10. So our theta, which is the increase in the temperature of this water as being heated, is 10 degrees Celsius. Temperature is measured in Celsius. I hope you understand.